Hello guys, welcome to this session on matrix plots. This is in continuation of our discussion on data visualization with Python using the Seaborn library. Today we will be discussing about matrix plots. So let's get started. Matrix plots allows you to plot data as color encoded matrices and can also be used to indicate clusters within the data. Okay, so basically, a matrix is a collection of rows and columns where all the cells or the intersection of rows and columns has to be a number, right? So here the rows and columns have a specific meaning and the intersections have a particular value. So we can plot that using a Seaborn library. Right. So we'll start with importing the Seaborn library as SNS, and we will do matplotlib inline to see the plots just after as the just in the output cell of the notebook. Right. So here we are working with a different data set which comes pre-installed with the Seaborn library. So here we will do sns.load dataset flights, and the flights is the dataset which we are talking about. We will store this in a variable called flights, and the other dataset is the tips dataset, which we have seen in the previous lecture also. It also comes pre-installed with the Seaborn library. So we'll do sns.load dataset, and tips will pass the name of the dataset. Now let's look at the head of the data tips data set. It looks like this. It has 6 columns: total bill, tip, sex, smoker, date, time, and size. Sorry, 7 columns. It is the data about the customers coming to a restaurants. What is the total bill they paid? What is the tip they paid to the waiter? What is their gender? Whether they were a smoker or not? Which day they came, and what time they came for dinner, lunch, or IT, and what was the size. Right. Now let's look at the data set. So flights has just 3 columns: year, month, and number of passengers. It's a data set about the flights and the number of passengers traveled in those flights. And the data is quite old. So as we see, it contains only the year, the month, and the passengers. Right. So first matrix plot that we want to talk about is a heat map. Okay. So yeah, so basically heat map, the density of the color or the color strength will show you how relatively the values vary in a plot. Okay, so like darker color for a higher value or higher intensity, and a lighter color for a lower value or a lower intensity. So in order for a heat map to work properly, your data should already be in a matrix form. Okay, so basically, so we need our data in a matrix form. So like currently this tips data is not in matrix form here, because some of the columns are categorical, some of the columns are numerical, and each row depends represents a specific customer, right? So we cannot make a heat map based on this data. So we want to convert it into a matrix form where the rows are also so one of the features, and the columns are also features, right? So to convert it into matrix form, we can take correlation matrix of the tips dataset. If we do tips.corr, it will give me a correlation matrix where the columns are total bill, tips, and size, and the rows are also total bill, tips, and size. So we see all the entries or all the cells are belonging to a number, okay, or are numeric in nature. So let's do a SNS heat map of tips CORR, or for this particular matrix that we got, how can we make a heat map? So making heat maps is very simple. Okay, we will do SNS or Seaborn dot heat map, and I'll pass the matrix form of the data set. So this is what we see as the output, right? So here we see that the lighter the color, the higher the correlation CORR, and the darker the color, the lower is the correlation. So we can clearly see that like this diagonal column is very highly correlated, because all these diagonals are a correlation of the feature with itself. So total bill is highly correlated to total bill. Tip is of course very much correlated to the tips. So that's why all the diagonals are lighter in color, and these two, like tips and total bill, also have some kind of correlation of about zero point 0.7 or something. Okay, so this is how we can make a heat map. So this color coding, we get a color coding for all the numerical columns, all the numerical data. We can also pass some other parameters like C map, like color map to be cool warm, and we can do and not is equal to true. That means we want all the matrix values to get printed in each of the color boxes. Okay, so for the similar, for the above diagram, for the above plot, we got a different heat map like this with a new color scheme called cool warm, where the red corresponds, more red corresponds to the higher correlation, and lighter or the bluish part relates to the lower correlation, right? So this is heat, this is about heat maps, right? And next is flights. We want to make color map of the, so this is how we make a heat map using the Seaborn library. Now we will try to make a heat map of the flights dataset, right? So this is what our flights dataset looks like: year, month, and passengers, right? So we see that the month starts from January, February, March, April, May, June, July, and in December, and they keep repeating for every year. So if you look at the data, the year column, so the year column remains same for like 12 entries from for the same year. Then we have month, then we have next 12 entries for the year 1950, then we have 12 months, then we have 12 entries for the next lit or next year, right? So we need to convert this data into a matrix form where all my rows are the months, my and my columns are the years, and the cross section or the cells has to be passengers, right? So how can we convert this? We have already covered this topic like in the previous lectures, so we will be using a pivot table. So like in the flights dot pivot table, the value should be passengers, the index or the rows should be my months, and the column should be my year. So like if I do this, I get a transformed data set like this, where the rows are the months and the columns are the years, and then and the intersection or the each cell value represents the number of passengers that traveled during that month of the year, right? So now it has become it has come in the matrix form. Now we can make a heat map of this data set, right? So let's store this particular, so currently we have just seen, we saw this data set. Now we need to store this in a new variable, so we are naming it as pv flights. That means pivot tables for flights. So it is the same thing as above, and now I can make a sns.heat map of pv flights, right? Pivot of flights. So this heat map looks like this, right? So it's, we can see that like this dark, so here the lighter the color belongs to the higher the number of passengers traveling during that particular month and that particular year, right? And the darker the color, that means there are very less number of people traveling during that particular month or the year. So we see that during the years 1949, 1950, 1951, 1953, during all these years the number of people traveling is very less, because maybe because the flights were very uncommon during those times, that we are talking about like around 70 years back. Okay, so as we move ahead with time, during the year 1956, 57, around 60, lot of people started traveling because we get a lighter shade of color during for all these years. And if we look around, if we look across the year, any particular year, we see that more number of people travel during this particular months, which is June, July, and August, right? And why? Because this is the time of summer vacations, where people travels a lot. So there is a kind of a relation, there is kind of a hidden meaning to these values, right? So we see like in the year 1960, the maximum number of people travel during the month of July and August, right? And in general, the year 1960 had more number of passengers as compared to the year 1950, right? This is how we can see get a matrix plot. And without so if you were to tell, if you were asked to show a trend, like in what is the number trend of passengers traveling in flights throughout the last 20-30 years, and you were given an excel sheet where all the rows and all the columns had lots and lots of numbers, you will get confused. But if you are shown just this picture, then within like 1 and 2 seconds you can easily tell that there is something different about this particular area, this particular year and month, where like the number of travelers traveling is really high. Okay, so this is the power of data visualization, right? Now we can also change some parameters, like in the same sns.heatmap pv flights, we can do cmap to be color warm. We can also add line color. Suppose we want to separate each of these cells with some line, and we can also add line weights, right? So that we can have a different color scheme like this. So it makes it more visually appealing, that like during these particular years, the redder the color, the higher the number of passengers traveled, and the lower the bluish, the bluer the color, the lesser the number of passengers traveled during that year, right? So like we can clearly see that during this particular area region in the plot heat map, we can see that the red, there is more red color, that means more number of people traveled, and there are nice white lines and of line width 1, right? This all these parameters we can provide. Next, we look at the cluster maps. So cluster maps uses hierarchical clustering to produce a clustering version of the heat map. So cluster maps, if you look at the machine learning playlist of the channel, then you will learn about clustering. So clustering is all about grouping similar things together, right? So if you want to group passing number of passengers traveling and like similarity in terms of like which year is similar to which year and which month is similar to which month, then we can use a cluster map. So we can directly do sns.cluster map pv flights. So this is what a cluster map looks like. Let me just zoom out so that the whole picture is on we can see on the screen, right? So this is more similar, right? So as we can see, like these two June is similar to September, and like 1959 is similar to 1960, and like these 2 months are together, right? So these clusters, this whole cluster is more similar to this cluster, and this particular year is more similar to this particular year. So all of these are being clubbed together as in form of cluster map. So if you change the c colors c map and currently the scale is like from is the actual number of passengers traveled. You want to normalize this particular scale between 0 and 1, then you can add a parameter called standard scale is equal to 1, which allows you to make the scale between 0 and 1, and you can change the color scheme to see cool warm, right? Now we can see like there is very much similarity in these 2 months, July and August, and these 3 months are very similar, February, January, November, and like these 2 years are these two are very much similar. So we can actually see some kind of similarities, some kind of grouping being formed, right? So this is about matrix plots. Next and the last topic in Seaborn that I want to discuss is the style and color. Like how can you style and color your visualizations, right? So this is here like just like any painter, any artist, you need to have some control over the kind of plots, the kind of designs, the kind of drawings that you can make, right? So as we see in matplotlib, it allows us to do all kinds of customization and gives us control over each and every part of the plot. Similarly, we have some control over the plots that we make using the Seaborn library. So we will import the library. We also import matplotlib.pyplot. We also do this thing matplotlib inline, and we will load the same tips dataset as before, right? So now I can set let's make a count plot for the gender, and from the data is equal to tips, right? So this is what my count plot looks like. Now if I want to set the style, I can set a general style to all my plots. So if I do set style to white, it will look like this, right? Or I can set style to ticks. If I do set style to ticks, then I can get a tick from all of these on this left hand side, right? If you go and do shift tab over here, you get to see that there are different parameters. Styles are like dark grid. So if I do dark grid, let me just copy it and I paste it here and I do run this cell. So like there is a dark grid in the background. Now if I want to do it like again, shift tab, I want to make the grid as white grid, right? So if I do this, then it becomes, if I run this, see, so now I have a white grid in the background, right? Suppose you want to, now let me just do let me just do the same as before, right? So now we have ticks over here, right? Suppose I want to remove the spines. I don't want this particular top line and the right hand side line, then I can remove that by using sns.dspline. See, this top line and the right line has been removed, right? And suppose I don't even want this particular line, then I can pass for some more parameters like this. So it takes into account d spine. So like by default it has these many like figure top, right, bottom and left. So by default top and right are true and left and bottom are false. So suppose I don't want this particular left hand line or the bottom line, then I had to provide like left true and the bottom true as an argument, right? Next we can play with the size and aspect size of our plots, so by using the same matplotlib. So suppose if I do plt.figure and fix size to be 12.12 width and 3 in height, then and I do any plot using Seaborn, then my Seaborn will adapt to the matplotlib figure size, right? So I will have a plot like this. So this way we can use our knowledge from matplotlib to define this the figure size, right? Suppose I do a linear model plot like this and the aspect is 4 and data is equal to tips, so I can get a plot like this with the same size that we have, right? lm plot total will and size I can provide here. If I change the size to be maybe 6, I get a plot like this. Okay, so like size scale becomes broader and the size becomes bigger. So if I do now do size is equal to 1 and I run this, it becomes like this, very small size. Let me change the aspect size to maybe 10. Right. So I get a, so aspect has become bigger but the size remains small. Let's make the size also 10. If I run this, I get a plot like this. So see, the aspect has become, the size has gone very small. So let's make it 5. Right, this is our plot, or let's make it maybe 2. Okay, size is like this. Okay, maybe let's just pay aspect size to say 5. Right, this is much better. Okay, we can also set the scale and context. So suppose you want to make a plot for maybe a poster which is a lot bigger than an A4 size, or you want to get it printed in a book, or you want to publish in a paper. So you can always set the context for your plots, right? If you do just shift tab over here, you will see that. Okay, maybe shift tab over here, you will get to see. Okay, you can see any of the context like this. Like you can set to a paper or notebook, or you can for a talk or a poster. These are all the context that you can set. So if you set to a poster, and if you find skill to be 1, if you run this, you get like this big. So your plot will look like much bigger in shape, much bigger, right? And the font will become bigger. So if I do font scale to be 3, it becomes like more bigger, right? So, or let's just keep it as zero point 0.5. So it becomes like this. So you can keep changing the context by using this poster, this set context method, right? And you can always go through this particular documentation which I have given in the notebook, to go through what all aesthetics related things you can do with Seaborn, right? So thanks a lot for your time, and I'll see you in the next lecture. Have a nice day.